Hi everyone, this is Group 15 and this is our project. The table shows the contribution that each one does, and I'll be starting you guys off with the crawling aspect. So to crawl the data, we require the URL of the products, and the URL is contained the async of the Amazon products, which is the internal ID that Amazon uses for the products. Then you can send the HTML request to access the product page and retrieve the information contained within the HTML objects and classes. Finally, the values are validated and cleaned before saving. As you can see, the async is contained within the URL for the product page. Then the comments can be scripted and passed from that page using HTML classes or XPaths. And finally, to optimal async, we can just go to Amazon Fresh page, and all the shown products will have their corresponding async numbers.
We use Python for the front end and Apache Source for the back end. Next, here is the UI for the search engine. We can search based on the text, add in the time constraint, and increase the minimum score to 1, and we can sort by the score. The sorting order will be increasing, and we'll just do the search. Here is the search result in a table form. The total amount result is 1,800, and we will change the sort order. And over here, the score number 5 is on top. We can also get a bar graph showing the number of reviews for each score. So with a single button, we just add one extra review into the database. Okay, it's a success. And we can check that the number of reviews just increased by 1. The search engine also allows for the display of classification result as a background color. So over here, we search the keyword love. And here is the result. The reviews are mostly negative because we sort in increasing order. So on top are all the score of 1. Here, we change the order of the result. And we can see that the score number 5 are on top and is displayed as a green background.
For classification, we jointly perform subjectivity and polarity detection by classifying reviews as neutral, positive, or negative. These are our data pre-processing steps, and we remove website links, HTML tags, stop words, contractions, change to lowercase, and do lemmatization. We also build a manually labeled evaluation dataset from the crawl data. 3 annotators labeled it, and the Cohen and Fleiss kappa score were around 0.9. The models we trained and evaluated on that dataset are shown here, along with the macro average, precision, recall, and F1 score. BERT produces the best classification results with F1 score of 0.83. As for the model performance metrics and inference speed, decision trees have the highest number of reviews classified per second and thus are the most scalable too. For the UI, this is the color coding of the search results that Chuyen showed. And apart from this, the user can also input their own reviews and the system will classify them and show the result with that blue pop-up box.
I will now be presenting on the enhanced innovation for classification. The first innovation is the balancing of data where there is a large number of reviews with positive sentiments. The imbalance in data will result in the model to be biased towards the positive reviews and perform poorly on both negative and neutral reviews. To address the issue, oversampling and undersampling of data is used. The number of negative reviews are used as baseline. Oversampling is performed on the neutral reviews and undersampling is performed on the positive reviews such that all the reviews will be the same. As seen from the table, models trained on the balanced data consistently outperform the models trained on imbalanced data, and overall, BERT model performs better as seen from the highest F1 score. The second innovation is the fine-grained sentiment analysis, whereby there will be 5 labels, namely very negative, slightly negative, neutral, slightly positive, and very positive. However, there's still the problem of data imbalance, and hence oversampling and undersampling will be performed on each sentiment, such that all reviews will have the same number. Overall, the performance of the model is slightly worse due to the increase in the number of labels to be classified. BERT models still perform the best as seen from the highest F1 score. The last innovation is ensemble techniques. Overall, using ensemble techniques helps to improve the F1 score. For LSTM, the F1 score improved from 0.59 to 0.68. For the decision tree, the score improved from 0.78 to 0.82.